In this new example, we have two things to take into account. Number one, I have two radicals. However, I need to get them isolated on either side. Number two, the radicals themselves are not square roots. They have a different index. It's higher, and I need to take that into account when I'm working on this. But let's do the first thing first. The first item is getting them to the other side. So I've got the cube root of 2x plus 5 minus the cube root of negative 5x minus 2. So if I have to move one of them, and the result of moving a term or any values from one side to the other results in a change of sign, I'm going to move this one here to the other side, which is going to give me the cube root of 2x plus 5 equaling the positive cube root of negative 5x minus 2. So the term itself is what changes the sign. So instead of a negative in front or a subtraction sign in front, I'm going to have a positive sign. The signs under the radical, however, do not change. Nothing changes there. Okay, so now I want to get started. They are isolated on either side, and in order to remove or get the result of the radicals disappearing, I need to raise the expression on either side to the root value. So the power I need to use to get the radical to cancel is whatever that index is. And in this case, it's a 3, so I'm going to raise everything to the third power. That will result in the radicals removal. So I'm going to have 2x plus 5 equals negative 5x minus 2. And now I'm back at my algebraic equation with a variable on either side. And it's time to go back and solve. So again, with the positive and negative, I prefer to work with my x on my left. Plus, I'd also like to see the negatives disappear if that's ever at all possible. So I'm going to bring my negative 5x term to the left, changing it to a positive. That gives me 7x plus 5 on the left and a negative 2 or minus 2 on the right. Next thing I need to do is move the 5 from the left side to the right side. And again, because I'm changing sides, I need to change the signs. That's going to give me a 7x on the left, with these two terms canceling, and a negative 7 on the right. My very last step to getting x alone is to divide both sides by 7. And that means that x will equal negative 1. But before I commit to my answer being negative 1, I go back and I plug in to the original equation, which gives me the cube root of 2 plus 5. And I'm looking to see if I can get this to be a truthful statement. Does this entire thing equal 0 according to the original equation? So we came up with negative 1. As I plug it in and evaluate, I'm going to work from the inside out. So in here, I get the cube root of negative 2 plus 5, or the cube root of 3. In the second one, I get the cube root of positive 5 minus 2, which is the cube root of 3 again. So the cube root of 3 minus the cube root of 3, well, anything subtracting itself will give you 0. So it does check and work, which means my solution is x equals negative 1.